So we're going to continue our next session with Caroline Eastwood, who's part of the cell ontology team at the Wellcome Sanger Institute. Go ahead, Caroline.
Can you see my screen and can you hear me well?
Yes, both.
Okay. I'm a cell ontology curator at the Wellcome Sanger Institute in David Anthony Sutherland's team. And I'm happy to be presenting today our work towards an integrated agentic workflow for cell ontology annotation and extension. Just to give a bit of background of why cell ontology annotation and extension matters. So with the rapid growth of single cell datasets, there has been an increasing need for consistent and reusable annotations. And the cell ontology is a key source for providing this formal interoperable cell type annotation, enabling cross-data integration, analysis, and discovery. But we have a significant bottleneck, and it's really two separate but related problems. Firstly, the annotation gap, where applying CL or existing cell ontology terms to data sets is manual, inconsistent, and sometimes could be too shallow. And secondly, the ontology extension gap, where when a new term is identified and adding it to the ontology could be very slow and manually intensive process. And so right now, these workflows are disconnected and can't scale with the current pace of scientific discovery. And to understand the scale of this bottleneck more, we've analyzed 196 data sets from cell by gene. And as you can see here from this chart, out of over 14,000 cell clusters, 77% lacked any direct annotation to cell ontology. And only 23% were directly annotated to CL terms. And when CL terms were used, often the annotations could be too shallow, as we found that only 603 distinct cell ontology terms were used across this data sets, which indicates that more frequently higher level or more general ontology terms are being captured, and the more granular biological findings might not be captured. And this annotation gap is a combination of missing or shallow annotations, which is when the CL term exists but it's not being used, and also when terms are missing from the cell ontology. So, for example, when novel rare cell types are being identified, and when this is the case, when when terms are missing from cell ontology, the challenge becomes even more complex because the annotation workflow has to stop and shift into more of a traditional ontology extension process, which is manually intensive. And so, as you can see here, so once a missing term is identified, the process involves term research and definition creation, validation and harmonization, and after that, formal submission is made to the cell ontology, and which waits for curators' review and approval. And then once this process is complete, then the term can be integrated and used to annotate the original data. And so this disruption in workflow can cause significant delays and slows down the entire cycle of standardization and integration. And so our vision in the team and our long-term goal is using a suite of agentic AI tools to bridge this gap and improve cell ontology annotation and extension. And I'll very briefly talk about what are agents. So you can think of agents, they are AI helpers that they don't just respond, but also actively work to solve your problem. So they are autonomous, they can make decisions, they can work with other agents to solve problems, and they can use external tools and services when needed. And in this slide, I'll briefly talk about the tools we have been using in the team and building, and then I'll go into more details of each individual tool in the following slides. So the workflow we have been building starts with single cell data sets as the input, and then a series of specialized AI agents takes over, starting with Amica, which provides automated cell type annotation. So it maps author cell type annotation to cell ontology, and it also flags any unmatched terms, identifying potential missing cell ontology terms. And it does that by leveraging dataset context and references. And then once missing terms are identified, then this can be given to an LLM deep search tool. We have been using Perplexity Deep Search for this experiment to generate standardized evidence-based ontology definitions with complete references. And it does that by using a standard prompt that we have created to ensure that the definition generated adheres to the ontology standards. And once we have this term metadata, then we can pass it on to the agentic validation tool, Clara, which validates the term metadata against the provided references. And once we have a validated term definition and references, then we can start the process of integrating into CL. And we have been using GitHub Integrated Agent for this purposes, Copilot. And Copilot works by auto-generating pull requests and directly editing the ontology files, giving us an output that looks like this. So this is a PR pull request that has been created by Copilot, and you can see it gives the summary of the changes it has implemented. So here it has added a new term with the definition, the references, and it gives you a summary of the changes that has been done. And once this is done, then a curator manually would review this output and either request further changes or approve it. So going into more details of each tool and what they do, starting with Amica. So Amica stands for Automated Mapping and Integration of Curation Annotations. It's an agentic AI tool, and Amica is given an authors table of annotations, like here, along with the publication and the supplementary material that describes this data set. And then in the first step, a specialized agent would use and read these publications to expand the author cell type. If they are short form cell names, it expands it to full names and also extracts any synonyms provided or mentioned in the publication. And then this enriched information is then passed on to another specialized agent that maps author cell type annotations to cell ontology terms and flags any unmatched terms for as potential new cell ontology terms. And the Amica gives an output that looks like this. So you can see here, for example, C goblet, this was the author cell type, and it gets expanded onto its full name from the paper, and then mapped to the most suitable cell ontology term. And you can see also here that Amica flags any unmatched terms, which gives us then more terms to work on and add to the ontology. And once missing terms have been identified, in this example, for example, thymic tuft cell, then this is given to a deep search LLM tool with a standard prompt to generate standardized definitions with complete references. And you can see here in this example, it produces a formal definition with the location of the cell type, key characteristics, and genes. And also it gives the references. And once we have this information, then we can pass it on to our agentic validation tool, Clara. And Clara works by taking the generated definition and the cited references. It firstly retrieves those full text PDFs references and then ingested into a RAG database, which is built on a tool used called PaperQA2. And next, Clara also prompts an LLM to split this definition into atomic assertions, and these are short, verifiable statements that can then be validated against the provided references. And at the end, we get a table of the assertions from the definition and whether it's true or false, and direct evidence from the text from the paper to support this verdict. Once we have a validated term metadata and we now want to add it into CL, we start by making an issue with the cell type, definition, references, logical definition, and then we assign it to Copilot, which is the agent we've been using in the cell ontology. And then Copilot handles everything from there, creating a pull request, implementing the changes, and producing a summary. And from there, then a curator would manually review these changes and either approve or request more changes. So the current status of how we are using these tools right now, we are using them more as discrete steps. So we manually run and validate the output of each tool in the cell ontology, and we have been using it to assess like single cell data set annotations, and then to create terms. But our vision and what we're actively working towards is having more of a unified workflow where the workflow would run from start to end, and then we, with a final stage of an expert review where you'd be able to review the output and then either approve it or request more changes, modify it. So we are currently, as a team, we are focusing on large-scale testing to fine-tune these tools and validate them. And we believe that building this integrated agentic workflow would improve the annotation gap and accelerating ontology development and knowledge integration, while also keeping experts in control to make sure the output is accurate and of high quality. And thank you everyone for listening. And I also want to thank my team for working, building, and implementing all these tools. Thank you, everyone.